is Francesco Stortiero. I'm a technical director from GFM, and I would like to speak about my presentation on application of nickel-based low-availability alloys for power gen aeronautical sector. And for this reason, I would like to start with the content of my presentation, and I will speak about the GFM company, and then I will go to introduce some issues related to the nickel-based low availability alloys, and then I will speak about the GFM role in custodian project. Well, GFM is a small and medium company located in Bergamo, near to Oriol Serio Airport. We have two sites. One of the directional one is in Mapello, and the another one is the production plant is in Nembro. Unfortunately, you have already known the Nembro cause of the COVID emergency. In the directional site, we have the technical office and the commercial and quality department. And while in the production plant, we manufacture some components for the gas and steam turbine. Sorry, but it doesn't work. Sorry, it doesn't work.
You click on below. Do you see like what says diapositiva?
I have to stop my share. Stop sharing.
Okay.
And restart.
Yeah. Let's try it again.
Si chiama una. No, non riesco a vedere il... Perché non si può?
Non vedono quello che c'è sopra, non quello che c'è.
The presentation is loading again. Right now.
Okay.
Okay. Right now we see it.
Okay.
Okay. Can you now?
Now you're able to see the presentation.
Yes. Are you able to switch the slide?
Yes, but it doesn't work. Sorry.
Okay.
Sorry. It doesn't work. Maybe try again. Now you're able to see the next slide?
Yes, we are.
Okay. So, as I told you before, GFM is a company involved in the manufacturing of components for gas and steam turbines, and we produce components like for compressor parts or turbine parts, like disc rings, oil seal rings, or seal rings, these cover plate. The company is about 80 employees, and our turnover is more or less 30 million per year, producing different components, as I told you, also by machining, because we are specialized in machining of all different materials, but also we are able to produce components by metal stamping. We produce a lot of components like seal plate and seal strips for the combustion chamber, and with a special coatings like thermal barrier coatings. So we are also able to produce components and jigs for the assembly of the turbine, and we are also able to conduct a special project either in the power gen aeronautical sector, and we have also produced components, special disc, like you can see on the left of the screen, for aeroderivative components of turbines. GFM is interested in innovation. For this reason, GFM attend different projects funded projects coming from national or international partnership. And for this reason, 3 years ago, GFM started a collaboration with DMG Mori and the IETEMA, two companies involved in this project, in the foundation of the Additive Technology Center, a center dedicated to promote the additive technologies in the different kind of industry sectors, among of the power gen and aeronautical sector. The MG is a well-known company that produced the CNC machine, and for this reason, in our Additive Technology Center, we have different kind of technologies. We have the hybrid technology with the LaserTech 65 3D machine. That is one of the first one machine on the market with the hybrid technology. So we are able to make subtractive with a 5-axis milling machine and additive in the same machine with the laser cladding head. So we have to manufacture new composite components exploiting this facility. We have also the power bed fusion technology with 2 SLM, and we are able also to finish the components coming from the SLM with a 5-axis milling machine. All the center is able to carry out feasibility studies and the research and development project in order to increase the capability, the manufacturing capability of GFM. And we are working on standard materials like stainless steel, Maraging M300, Astellox, and also aluminum Inconel 718 for the SLM. But we are interested to increase our capability because some of the components that we are able to produce are made by different alloys. In particular way, we are interested in the nickel-based superalloys that we machine, but in some cases we need to build in complex shapes, and so we want to exploit the additive manufacturing properties in order to manufacture this kind of components. But as you can see, some of the components that we produce and some
Francesco, I can't hear you right now.
Are listed in the pictures that you can see. For example, we have
Yes, now I hear you. Yes, it was kind of interrupted, but now I hear you again.
okay, and from this alloy that we use for the casting manufacturing, we are able to produce blades or ceilings for turbines, and also we are interested in alloy CM247 low carbon used for the also in this case for the manufacturing of blading. But as you already shared in the previous presentation, there are some drawbacks related to this kind of alloys, because if you see on the right of the screen, you can see the weldability diagram of nickel-based alloy. And the alloys we are interested to are the left of the diagram, demonstrating the low weldability of them. In this case, we are not able to process them by hand or by fusion, and we use these kinds of alloys manufacturing components by castings techniques. But we have, in some cases, a lot of scraps. This low weldability, as you probably understood from the previous presentation, is due to the high rates, high cooling rates of the powder bed fusion, related to the powder bed fusion techniques. And so in the project, custodian project, you understood that the aim of the project is to reduce and control the thermal evolution during the process in order to reduce the crack formation. So GFM has selected for this project 2 case studies in which is interesting too. in order to understand and to evaluate the project of the custodian, the result, the custodian project. What we have selected two components: the sealing for gas turbine made by Inconel 713 low carbon, because we are interested to manufacturing complex part, reducing the weight of the ceilings. But in the case, we need to exploit the additive manufacturing. And so these data by what we do in project in order to upset and the fact and find a representative geometry of the case studies in order to speed up the evaluation process. Then, at the end, we will define a test and inspection plan to evaluate the quality of geometries manufactured by Power Bed Fusion with a custom machine developed by Custodian Project. And so, keep in touch to see the result of the Custodian Project, and thank you for your attention.